Good morning, all you cool cats and kittens. This is Mrs. Post here with your Algebra 2 lesson of the day. Today's March 30th, 2020, and we're going to work on compound interest. So here is a famous quote by Albert Einstein over here to your left. The most powerful force in the universe is compound interest. So what we're going to do is you guys are going to practice what would happen if you have a certain amount of money to invest in the bank. You're going to earn a certain dollar amount for that money that you originally invested, and you're going to take it and you're going to invest it again and again, and that's compound interest. We're going to do some examples today on how that works. So I'm going to do this example. You're going to do one with me, and then you're going to do one on your own, and you're going to turn it in. Okay? So here's the first example here. An investment account pays 4.2% annual interest compounded monthly. If $2,500 is invested in this account, what will the balance after 15 years be? What will the balance be after 15 years? So I want to show you what the formula is, and I want you guys to write this down. I kind of put it on the next screen a little bit larger, so I want you guys to make sure that you pause the video here and you write it down if you need to. So the formula is pretty similar to the exponential formula we've been working on, but it does have a fraction in it. Right here we have 1 plus r over n, and I want to talk to you guys about what all these letters mean. So A is your amount in the future, the amount that you're trying to figure out what it would be in 15 years or 20 years or whatever the question is asking you. Usually this is the part we don't know. It just depends what they're asking. The principal, of course, is the starting amount. So whatever amount you're bringing to the bank to deposit. R is your interest rate as a decimal, so make sure that you move it over to a decimal format, and I'll show you guys how to do that with our first example. N is used twice. You'll see as the denominator and also up here as part of the exponent. And T is the number of years you're going to calculate into the future. So with that in mind, let's go back to our previous example. And let's try to work this one out. So we're basically just going to do step 1, which is just filling in the blanks, and then step 2 is just calculating. So I don't want you guys to overthink this situation. Step 1 is just going to be substituting in values, the values that we were given from the problem. And it is not going to give you anything extra in this particular problem, and you're not going to be short any information except for the one thing that it's asking you to find. So for this particular problem, let's go ahead and try to answer all the questions. What is the amount in the future? What is our A? I don't know. We don't know A because that's what we're trying to figure out. So A is what we don't know. Okay, but we do have the principal, we do have the starting amount, and that right here is the 2,500. That is your starting amount, so that is the 2,500. What is the interest rate as a decimal? So we do have the interest rate, 4.2%. Let's go ahead and turn it into a decimal, and you can do that by moving the decimal point 2 places to the left. Just make a little note for you guys. Move decimal 2 places left, okay, which will be 0.042, okay? Now, let's go ahead and answer in. How many compoundings per year? So how many times is it going to do this? It says it's going to do it monthly. So how many months are there in a year? There are 12 months in a year. So every month that's going to take your principal and it's going to find the interest and it's going to multiply it. And it's going to add that to your principal. And then how many years are we trying to calculate it? It says 15 years. So 15 years into the future is what we're trying to calculate. Okay, so now you're just going to go ahead and complete step 1, which is to substitute in all those given values. So it says our problem is A equals P times 1 plus R over N to the power of N times T. So remember, we don't know what A is. That's what we don't know. We do have our principal. We do have a starting amount, which is 2,500. And what's going to go inside the parentheses is 1 plus the rate, which we have as 0.042. And then that's going to go over our n. That's going to happen once a month. In a year, there's 12 months. And this whole thing is going to be to the power of, well, this set of parentheses, it's going to be to the power of n times t. So our n, once again, is 12. And our number of years that it's going to do this is 15. So it's 12 times 15. And so we're just going to go ahead and we did step 1. That part's done. Now we're going to go ahead and do step 2, which is just to calculate. Please make sure you guys are using the correct order of operations. If you decide to go out of order, your answer will not be correct. Okay, so don't forget that is to please excuse my dear Aunt Sally. You have to please, you have to have manners. So check inside your parentheses first, and you guys can go ahead and calculate that on your calculator. So if you guys calculated 1 plus 0.0442 divided by 12, that should give you, you can do this probably faster in one step on your calculator, but I'll just show it just to make sure you guys are getting the right thing all the way through. 1.0035 is what should be in parentheses on your calculator. And then whenever you guys work on your exponents, 12 times 15, that should give you 180. Just calculate that with your calculator. And you guys are going to go ahead and then do the exponents because we already worked out what's inside the parentheses. Now we have to do our exponents. So that should give you 2,500 times 1.0035 to the 180th power. When you do that, you may have to round if you're going to write it down. Otherwise, your calculator, you can leave it the way it is. It would come out more accurate if you just leave it on your calculator. You could get something like 1.88. Since we're talking about money, we just have like 2 decimal places. And once you guys go ahead and multiply it lastly, that should give you an amount of about $4,688, and you can round 87 cents. And this is after 15 years. So you started with $2,500, and you're going to end up in this particular case with $4,688.87. And this is your amount in the future. And that's what you guys were trying to figure out, which is not that, 4688.87. That's your amount in the future. And that's how you do compound interest. So you have the formula, you just plug in the values that you're given, and you can figure out how much money you'd have in the future if you had a certain interest rate of this. Okay, so we're going to go on. I'm going to let you guys stop the video and let you guys try the next one. Remember, if you ever need to pause the video, you can. Just pause it. If I'm going too fast or you don't understand what I'm saying, you can just pause it, rewind it, do whatever you need. And that really is a good benefit of online learning, something you don't have in the actual classroom. So one good benefit of online learning. Okay, so let's go ahead and have you guys try example 2. So here's your situation. An investment account pays 1.2% annual interest compounded twice a month. If $100 is invested in this account, what will be the balance after 20 years? So go ahead and take a moment, pause the video, and go ahead and calculate. Don't calculate, I'm so sorry. Go ahead and do step 1. And hopefully you guys remember step 1 is to substitute in the values. Your given values, right, into the formula. So hopefully you guys paused the video and you gave it a shot. That's what I would do if I were you. So go ahead and try to figure out what you can plug in. We are asked what will be the balance after 20 years, so we don't know what A is. Our principal amount is given. We're only investing $100. Our rate is 1.2, but it says to put it as a decimal, so don't forget to move it 2 places to the left. So 0.012 would be our interest rate. And then it's asking you the compoundings per year. So it says twice a month. So it's going to happen 2 times a month. There are 12 months in a year. Twice a month means it's happening 2 times a month. So hopefully you guys will catch that that would actually be twice a month. So if it just happened once a month, it'd be 12, but since it's happening twice a month, it would be 24 times. So it's going to take the interest a little bit more than the last problem did. And then the number of years it wants to know in 20 years into the future. Okay, so go ahead and plug it into your formula. So we don't know our A. Hopefully you guys went ahead and you were able to pause the video and give it a try. So your principal amount was 100, and the number inside the parentheses was 1 plus your rate, 0.012, all over your N, which was your 24 compoundings a year, and this would be to the power of N times T, so 24 times 20. Okay, so that would be how your formula, how your equation is set up. Now, if you guys were to go ahead and use your calculator, you guys would get something like 100 times 1 plus 0.012. I'm going to go ahead and write that here. This is step 2. And don't forget, that is to calculate. So I'd like you guys, I want to go ahead and pause it now. Go ahead and pause the video. Try to calculate this into your calculator and see if you get the same thing I would. So pause the video and calculate it out and see if we get the same thing. This is a really good way to know if you're doing it correctly. If you're not doing it correctly, then you probably need to come visit me today during the office hours. Hopefully you guys had a chance to pause the video and calculate it out. I didn't pause my video. I'm going to keep going, but you guys can pause it at any time. So if you were to calculate, remember you guys would use please excuse my dear Aunt Sally. You would do all your grouping symbols first. And what's being grouped is 1 plus 0.02 over 24. And it's 1 plus that fraction. So don't try to look at it like it's 1 plus 0.12 divided by 24. So if you guys were to work inside the parentheses, you would get something like 1.0005. And 24 times 20, you guys would have gotten something like 480 up here. Then if you were to go ahead and work out your exponents and take 1.0005 to the power of 480, hopefully you guys did that. And inside your parentheses, you got something like 1.27. And when you multiply these out, you guys would have gotten a dollar amount of $127, and you can round to 12 cents, and this would be after 20 years. So it looks like they gained about, what, $27.12 after 20 years, but remember their principal was only $100. So, and it was a very low interest rate. So that's how you do it. So you guys are welcome to look at this problem, see how I calculated it, and make sure we come up with the same solution. I just want to make a quick note that this, once again, is your A. This is what we were trying to figure out. So $127.12 after 20 years. Okay, so here's the next example I want you guys to try. Right here. So here's your problem of the day. An investment account pays 5.4% annual interest compounded quarterly. If $4,000 is placed in this account, find the balance after 8 years. So I want you guys to work on this today and make sure it gets turned in so I can see it tomorrow morning. If you need help, I'll be in the office today from 10 to 12 or 2 to 4. So any of those times, that's 4 hours today, I'm available for you. I want to go back one more slide real quick, previous. And if you didn't write this down, make sure you do. That notice if it says annually, that's just once a year. If it says quarterly, the year is broken up into 3 months apiece, so that's 4 quarters. If it says a month, that means there's 12 months in a year. weekly. There's 52 weeks in a year and daily 365 days. So there you guys go. I want you guys to work on this today. I keep going backwards. And I want you guys to send me your work and so I can see it. So I have evidence that you guys are working hard and you have that extra practice. And tomorrow you'll get a few more problems. If you guys need anything, I hope to see you guys. Otherwise, have a fabulous day. See you guys later.